In this recording, I'm going to talk about control of heart rate. So the heart has what we call intrinsic and spontaneous stimulation, which means that it can generate its own action potential. And that action potential is normally generated at what we call the SA node or sinoatrial node. We call that the normal pacemaker of the heart because that's where, it's right about here. That's where action potentials normally begin in the heart. And if the SA node is allowed to fire on its own, it fires at a rate of 100 beats per minute. So we will call that, the sinus heart rate because that's the rate that the SA node fires. And we call this the intrinsic heart rate because this is the heart rate that is controlled within the heart or intrinsically. There's also a backup pacemaker called the AV node, which is also located in the right atrium. So if for some reason the SA node doesn't fire, the AV node is a backup. So the heart can beat all by itself. You don't have to tell the heart to beat. It's got intrinsic and spontaneous stimulation. But is that there is extrinsic control of the heart. There are nerves attached to the heart. So we're going to talk about how the heart is controlled extrinsically. And that control is going to come from the autonomic nervous system. And remember, the two branches of the autonomic nervous system are the parasympathetic and the sympathetic. And the other control system, which is the endocrine system. So we're going to talk about these. Just a reminder, this is what we're talking about here, the autonomic branch of your nervous system, and there's two branches to the autonomic. There's the sympathetic and the parasympathetic. Okay, this is our SNS, this is our fight or flight, this is the branch that is active during exercise, and then our parasympathetic is our rest and digest. All right, so autonomic. There are nerves going to the heart. The control center, the cardiovascular control center in the central nervous system is located in the medulla oblongata. Okay, we're not going to go into anatomy, but you could look that up. And the parasympathetic nerve coming out of the medulla oblongata is called the vagus nerve. And the vagus nerve leaves the central nervous system, leaves the spine, and branches to the SA node and the AV node. Okay, so the vagus nerve attaches to both the SA node and the AV node. As we've talked about other aspects of physiology, nothing is ever 100%. So the sympathetic and the parasympathetic systems are always firing to some extent, but one is going to be firing more than the other. If the parasympathetic nerve is the dominant controller, the primary controller of heart rate, if most of the action potentials are coming from the parasympathetic nervous system, we say that the heart has vagal tone because it's mostly under control of the vagus nerve. And if the parasympathetic is the dominant system, the heart rate is going to be less than intrinsic or less than 100 beats per minute. Because if you left it alone and you didn't send any signals, remember that the intrinsic heart rate is 100. The parasympathetic system is basically going to send action potentials that tell the heart to slow down. So if the heart rate is under 100 beats per minute, then you know it is under vagal tone. If, for instance, you were to cut the vagus nerve and there was no vagus nerve going to the heart, the slowest the heart rate could beat would be 100. Okay, it couldn't go below its intrinsic rate because the vagus nerve is the only thing well, not the only thing, but nothing's ever 100%, but pretty much the only thing that's ever going to cause that heart rate to go below 100 are action potentials coming from the vagus nerve. On the other hand, we have the sympathetic nervous system, and the nerve coming out of that branch, we're going to call it the sympathetic cardiac nerve. There is a fancier name. We're not going to get into that, but for our purposes, the motor nerve coming out of the sympathetic nervous system is the sympathetic cardiac nerve. Now this nerve also goes to the SA node and the AV node, but in addition, this nerve goes to the left ventricular myocardium. So the walls of the left ventricle. When the sympathetic nerve is the dominant controller, the primary controller, so when more action potentials are coming out of sympathetic than parasympathetic, we're going to get a heart rate over 100 beats per minute. Okay. So sympathetic nerve causes heart rate to go over intrinsic. Parasympathetic causes heart rate to go below intrinsic. If you leave it alone, it's going to beat at the intrinsic rate of 100. Now, since there's also a nerve going to the left ventricular myocardium, remember that the left ventricle contracts with a certain amount of force that determines stroke volume. Okay? Usually when we talk about stroke volume, we're talking about the blood coming out of the left ventricle. When the left ventricle is receiving sympathetic nerve signals, it increases the stroke volume. Okay? So when we get an SNS response, we get an increase in heart rate and we get an increase in stroke volume. Okay? The heart rate is increasing because we've got signals going to the SA node, and the stroke volume is increasing because we have signals going to the myocardium. And again, as with the vagus nerve, if we were to cut the sympathetic cardiac nerve, you wouldn't be able to bring your heart rate over 100 beats per minute, because the only thing that's going to bring it over 100 would be that sympathetic signal. Now, remember that the other system, the other control system in our body is our endocrine system, which is always working hand in hand with our nervous system. During exercise, you're going to get secretion of epi and norepi from the adrenal gland. We've talked about this before. And it's going to have the same effects that SNS had. So when epi, norepi go out and they go to the heart, and they cause the heart to increase its rate and increase its stroke volume. So it's going to have the same effect as SNS. So let's say you had a heart rate of 50 beats per minute. Okay, so what we have here is intensity here, maximal oxygen uptake, and what we have here is heart rate. And so here you are at rest with a heart rate of 50 beats per minute. And then you get up and you start to walk, and you start to jog, and you start to run. Okay? And so as you do more work, okay, you need more ATP, and you're going to need more glucose, and you're going to need more oxygen, you're going to need more fat. So we need to increase the heart rate. So if the heart rate is at 50, it's under vagal control, okay, because the vagus is keeping it below 100. So if you want the heart rate to go up from 50, the first thing you do is you withdraw your vagal action potentials. Okay, so you reduce the parasympathetic output, and as you reduce it more and more, the heart rate's going to come up. And it'll eventually, if you completely withdraw vagus stimulation, you're going to get a heart rate of 100. Okay. But if a heart rate of 100 is not enough for you to do the amount of work that you're trying to do, if the demand for heart rate is beyond 100, the sympathetic system kicks in and brings the heart rate over 100. So if you're below 50, you're under vagal control. If you need to go up from 50 to 100, you withdraw the vagal signals. And if you want to go up over 100, you start increasing sympathetic signals. That's the way it works.